Okay, so for this question, I already drew the diagram. So we have our 10 kilogram mass here, the tension of this string against it, and its force due to friction going in the opposite direction of the motion. And for mass 2, which is the 20 kilogram mass, we have your applied force going that way, and we have our tension and also our force due to friction going the opposite direction of applied force. And what we have to remember is the only important vertical force that's important is our normal force, because we do have force due to friction, and when we look at the formula of friction, it's going to be force due to friction is equal to the coefficient of friction multiplied by the normal force. So we have to determine the normal force of mass 1 and also mass 2. So let's set up this equation. So what we need to do first is we need to determine the net force on each mass. So let's do it on the mass 1 first. So we'll say F net 1 is equal to the tension minus the force due to friction on mass 1. And for mass 2, we say F net 2 is equal to the applied force. And remember, we'll do a reference point. We'll say that going to the right is our positive direction, okay? So for F net 2, our applied force minus tension minus force due to friction on mass 2. So what we need to do is we'll add these two equations together. So that's going to give us F net 1 plus F net 2 is equal to, and what we know is the tensions will cancel out, so it'll be our applied force minus force of friction on mass 1 minus force of friction on mass 2. So on the side, we're going to figure out the Fn1, the normal force on mass 1, and normal force on mass 2 first. So what we have is, well, for Fn1, which is equal to mg, which will be 10 kilograms multiplied by 9.81 meter per second squared, which will give us 98.1 newtons. I'm having a little bit of trouble with my pen today. So normal force on mass 2 is going to be equal to the same thing, mg, which will be 20 kilograms multiplied by 9.81 meter per second squared, which will give us 196.2 newtons. And before I do anything, let's figure out the force of friction on mass 1 and also mass 2. So we'll do that right here. So force due to friction on 1 using this formula, and we know that our given force due to, coefficient of friction is 0.15. So what we'll do is 0.15 multiplied by our normal force on mass 1, which is 98.1 newton, which will give us a value of 14.715 newtons. And for force of friction on mass 2, it's going to be 0.15 multiplied by 196.2 newtons. 2 newtons, which gives us 29.43 newtons. So now what we're going to do, going back to this equation, we're going to expand that F net 1. So F net 1 is going to be equal to our mass of 1 multiplied by the acceleration plus mass of 2 multiplied by the acceleration is equal to applied force minus our force due to friction on mass 1 minus force due to friction on mass 2. And we'll factor out the acceleration, and we'll have m1 plus m2 is equal to F of A minus, force of friction on 1 minus force of friction on 2. And we're going to divide both sides by m1 plus m2, because we want to determine the acceleration of the whole system. So that's going to be m1 plus m2. Now we'll substitute all the values. So acceleration will be equal to, our applied force was a given amount, which was 60 newtons, minus force due to friction of mass 1, which we calculated as 14.715 newtons. I'm really having trouble with my pen here today. And force of friction on mass 2 is 29.43 newtons, divided by the sum of the both mass, which is going to be 10 kilogram plus 20 kilogram, which gives us 30 kilograms. And when we plug that into the calculator, our acceleration of the whole system will be 0.5285 meter per second squared. And we won't really worry about the significant digits until the final answer. And on this question, we're trying to solve for the tension on the string. Okay. So since we have our acceleration, we can use one of these equations, either this equation or this equation, to determine our tension. And we'll use this one because it's an easier formula. So it says F net 1 is equal to tension minus force due to friction on mass 1. So we want to isolate T, so we're going to add force due to friction on mass 1 on both sides. So that will give us tension will be equal to F net 1 plus force due to friction on mass 1. And F net 1 is going to be our 10 kilogram multiplied by our acceleration, which is 0.5285 meter per second squared, plus force due to friction on mass 1 is 14.715 newtons. And that gives us a tension of 40 newtons. So therefore, to answer this question, the tension on the string between the two masses is 40 newtons. And you can also use the second equation, this equation, where is it? That's right, I'm having trouble with my pen today. You can use this equation and substitute your acceleration for mass 2 and solve for t using the second equation, and you will get the same answer for the tension of the string, which is going to be 40 newtons.